Okay, so this video is going to be the second video in the series that goes through the scripts for the serpentine wall project. So we look at this, I've gone ahead and in the previous script I actually ran through and generated a model for that, showing you guys how to take the tile and run it through the two scripts. Ironically, as I went through it, I did not save my last one and I crashed the program, so I had to rebuild, and so I thought that I'd do something different for this. And I just show you guys how you can model these. This is a collection of geometries that are sort of mirroring and hugging each other, linked with a sort of pylon in the center here, so this turns into one tile. And then I've gone ahead, meshed those, so each one of these can remain separate, but then once you mesh it, you can join those meshes. I also wanted to highlight a different strategy for generating that secondary surface for doing this. What I've directed you guys to up to this point is by offsetting the surface. And you can see that sometimes that generates some complexities. We have a really tight geometry here and some bad geometry down at the bottom. If you guys are having trouble making that work, what you can do is, instead of offsetting the surface, you can copy the surface a certain distance away along a vector here. And so what I've done is I moved this 1 foot away from that to set the thickness using the same surface. So these two are essentially identical, and we'll use those to define the space between. And that's what I've done for actually the generation of this right here. I also wanted to note, I'm going to go ahead and shade this, when I was going through this, what we had happen is we had a series of bad geometries that created a situation where, or it's not bad geometries, just inverted geometries once the script was run. I'm not sure why that's doing that, but this analysis tool, the flip direction, is going to be something you want to pay attention to. So if you take a closer look at your geometry and you can see the inside, we zoom in here, of the geometry, that's bad, to say the least. So if I go ahead and select all this and then right click on this flip direction, it'll flip the direction of the meshes, and you can now see we see this as a solid collection of geometries. Okay, and at this point now we're ready to run the analysis of this guy. First thing we need to check is we need to make sure that we're actually sitting inside of our location boundaries here. And I also included, not by accident, the partition wall location from the previous phase. So we can go ahead and turn on both of those geometries. So I'll go ahead and turn that on. You can see that this is Robin's project. So we have both of these guys inhibiting our view of the space. So we go into our shaded perspective here, we can start to see exactly how it's working. So we have our 10 by 10 as articulated in the previous site, and then we have that same 10 by 10 thought of in a completely different way along the surface. So we have this sort of nice relationship between these, and both of these are concerned with transparency. Alright, and so as we turn that guy on, and we need our serpentine wall guy, I'm going to go ahead and turn that off. Now we're ready to run the script. Now when you guys pull this up, they're included in the package, there are several evaluation scripts. You want the view evaluation. That's where it's going to enable us to set the station point from which we'll be looking from, if I can talk. And then it'll ask for the evaluation surface here. Okay, so I'll go ahead and hit run on that, and we can select one of the two evaluation points. And you'll note that both of those guys relate to, are going to have a relationship with the pattern screen, so you're going to have to negotiate both of these screens as you guys go through your analysis. Okay, so we'll select the point of the viewer, and we have to unlock that. So we'll go ahead and select that, and then we can go ahead and select our evaluation surface. And then it's going to ask us to select the geometry for the wall. Now I've limited this so that it can only select meshes, so if you haven't run this properly, pay attention to that. So we need to make sure this is the partition wall is meshes and the serpentine wall is meshed. So we'll go ahead and just drag a window over to select all that geometry. Hit enter. And that's going to ask us for the analysis subdivisions along that surface. So this is going to generate two things for us. This is going to generate a nice graphic here in the sort of plan view that we can start to export and take to other applications, so for rendering, and so we can show our analysis. And then we can also be able to see how that visualizes on the 3D space. Okay, so go ahead and just stick with the standards here. I've preset that, and now you can see it's starting to build. And we want to go ahead and turn off the redraw, so I'll go ahead and just minimize that. And then we'll wait until this comes back, and I might end up just clipping this section out of the video. Alright, and through the magic of video editing, we're gone ahead and done running that script, so we can go ahead and see how we did. So now we can start to look at this, and I'm going to go ahead and go into plan view here. Zoom out so we can see, check our analysis. Now this script generates two patterns, the unrolled pattern and the actual pattern. So we can look at our actual transparency, and we needed to hit 20%. So we'll turn off the fail, and we'll do an area calculation. So that's 2500 by 2530, and we'll turn on all of this. At a 10,000, so we're just slightly over the percentage range there by 0.3%. So, and so we can go ahead and start to adjust and tune this, and so maybe I'll just move some of the geometry within the 3D space to start to get that. So if we look at this, we can go into location, and you can see that I could probably kill a little bit of that space over there to start to get that range a little bit tighter. Okay? Alright, and so that's essentially all there is to it.